Hurricane Erin provides hope for the U.S. East Coast. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 17th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time. No hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to reply. And if you'd like to leave a small contribution to help support the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Tim Caston, Evolution Moto, E-Slate, and a special call out to Hurlbert808, my good buddy from Cocoa Beach many, many years ago. Thanks for the generous contribution. And with that, let's get to work. We'll start by looking at significant wave heights around the planet. Starting in the North Pacific, calm pattern is in play. A little bit of weak low pressure somewhere here in the Gulf of Alaska, but it's not generating any meaningful seas. In the South Pacific, we see an area of 28-foot seas here and also here. Maybe some hope from this one for some swell up into California, but not a whole lot. In the North Atlantic, of course, Hurricane Erin, the central part of this evening's discussion, or at least the highlight. And then another tropical system exiting the U.S. northeast coast. South Atlantic, pretty quiet pattern, one area of 20-foot seas southwest of South Africa, not doing a whole lot. Then in the Indian Ocean, the usual pattern, 26, 27-foot seas, 38-foot seas here. No, that's in Erin, sorry. These are the highest seas over the entire planet, and actually looking at it, it looks like Erin is taking the cake with the 38.7-foot seas. Down here, there is an area of some 34-foot seas, something like that. We'll go dive into that in a minute. But all in all, it seems like the southern hemi is settling down a bit, especially after last week's run of surf. But before we get into all that, let's go take a look at current conditions. We're going to start up in the Pacific Northwest as usual. Grays Harbor buoy number 036 there, right on the border between North Oregon and southern Washington. We're looking at all the energy that's hitting this buoy all the way up from 33.3 second period energy, which there is 0.0 feet of it, the whole way down to 5-second period. That'd be just like pure wind chop. We see a nice little bit of windswell here in about the 9.9 second range. Maybe some dribbles of southern hemi energy in the mix there. Let's put this all together. Primary swell, 5.7 feet at 9.8 seconds from 289 degrees, making surf at head high, maybe even a little bit more. With secondary swell, nope, even the southern hemi doesn't make it secondary swell. It's still wind swell, 3.8 feet at 6.8 seconds, and it's just buried in all that other stuff. Moving down to the Point Sur buoy off of number 157. This is off of a little bit south of Monterey Bay, Point Sur area. We're looking at all the energy that's hitting this buoy. We see lingering southern hemi energy and some sort of wind swell, but nothing is even in any single period band. It has 2 feet of energy in it. That sort of gives you an idea of what's going on. Primary swell, 3.6 feet at 10.2 seconds from 306 degrees. That's 3.7 foot. And yeah, the surf was waist high or so today. Maybe chest high if you're lucky at top breaks on north facing breaks. And then the secondary swell, here's your southern hemi energy, 1.3 feet at 14.5 seconds from 213 degrees, making surf 1.8 feet. There were, waist, almost chest-high peaks at top spots in Santa Cruz earlier today. Oh, also one other thing. So here on this buoy, you can see here somewhere a couple days ago, these are the readings here were every half hour, and then all of a sudden it started going to every hour. This is what happened at the Point Reyes buoy, and it started doing hourly readings, and then it just went offline completely and has not come back, and I don't think it's going to come back. I am very worried that this buoy is also in the same state of decline. And consider the fact that the Half Moon Bay buoy is down and a whole bunch of other buoys in the Northern California region. I think the Bodega Bay buoy is down. It's just, things are not good, and I don't think there's money in the budget. And I'm very worried that when these buoys go offline, especially as we're approaching the fall season, they're not coming back. And we might end up flying blind, especially if we start getting some big swells and big storms later this winter. So just a point of notification, for your edification. There's nothing I can do about this. This is all about, big boats at sea trying to go out and do maintenance on buoys, and that takes money and government funding and all that sort of thing. So just a heads up. Heading down to Southern California, the Point Loma South buoy, 191 there off of San Diego. A much mellower pattern, a little bit of background southern hemi energy, no real wind swell. Of course, the Channel Islands blocking all that. Primary swell 1.3 feet at 13.5 seconds from 192 degrees, making surf 1.8 feet. Yeah, there's bigger sets than that. And secondary swell 0.9 feet at 17.2 seconds from 199 degrees. Again, surfing the 1.5 foot range. Maybe all this stuff combined together, you get something that's rideable, but nothing epic by any stretch of the imagination. Over to the south shore of the Hawaiian Islands, the Lanai buoy, number 239. Little bit of background energy there in the 14 to 15 second period range. I think this is actually building. New little background swell moving in there. Primary swell 1.7 feet at 14.7 seconds from 189 degrees, making surf 2.5 feet with some wind swell in the 1 foot at 10 second range. Not even going to worry about that. All right, so what's been going on for the past week? We're going to go to the significant wave height models. This gives us just a good overview. We're going to start in the North Pacific. There was a tropical system northeast of the big island of Oahu a week ago. It built, but it was already too far north of the Hawaiian Islands. This was on Monday, the 11th of August, and then headed off to the north. And no, it was a fish storm. No swell for any landmass that we were able to see. Now, also notice low pressure actually developed on Friday off the Pacific Northwest, making seas 13.6 feet. I think that's, yep, sure, that's it, yep. 13.6 feet. It really was just weak low pressure. Did make rain pushing into Washington and Oregon, but I think even as of this morning, that's all over, and here we are at current time. And heading to the South Pacific on Friday, we're going back just a little bit more, the 8th of August. A gale did push under New Zealand, producing 25 foot seas, we'll say. Aimed a little bit to the north. We'll just run this through. You see, it got 26 feet. I think we got one reading. No, it didn't even catch it, but it was 26 feet. And there's another reading at 25 feet into late Friday. That is the swell in combination with this little area of fetch right there on Saturday morning. That says, no, oh yeah, it says 27 foot seas. All that is just starting to show at the Hawaiian Islands. We saw it on the buoy there, but nothing significant size-wise is expected. Some of that energy is to push into California as well. In addition, a secondary fetch developed here on, we'll call it Tuesday, with 26-foot seas aimed north, building to about 29 feet. And I think we got a little area 30-foot seas. That, it has a little bit more energy behind it, will be arriving more to California, less to Hawaii. But either way, it'll give us a run of like background southern hemi energy through the work week for, most of Hawaii and certainly into California. Now we're into Wednesday, 13th and 14th. That all faded out. Another two systems developed. We'll focus over here first. This is on Friday morning. 44-foot seas building to 45 feet, back down to 40 feet. This is in the California swell window. You know, the Great Circle Paths go right up like that, and unshadowed. It was between 212 to 217 degrees, unshadowed by Tahiti into Northern California, maybe a little bit of shadowing for Southern California. But New Zealand sitting right there, pretty much blocking the initial energy relative to Hawaii. Also notice the arrows, the swell vectors, sort of aimed more southeast. So whatever swell we get from it's definitely going to be a glancing blow. But then, as we got into Saturday, it started moving more to the east with 34-foot seas fading from there. Now, I'm also ignoring one other little thing, and let's go back and take a look at this. Right here on Friday, also another fetch developed in the upper reaches of the central South Pacific with 29-foot seas, building to about 31 feet, and then it too started falling south. So it was just really, let's see if we can place this window right here, 1, 2, 3 frames where it was spraying fetch aimed up and out in that direction. This energy now targeting Patagonia, or this was really on Saturday. You get the idea. And here we are, current time, all that pretty much fading out. All right, going back a week for the North Atlantic, we'll put this into motion. The main focus, here we go, is the beginnings of Erin out on Tuesday, August 12th. Building while pushing Cape Verde Islands right here. This is a classic Cape Verde Island storm. The tropical wave pushes off of the Sahel region of Africa over the Cape Verde Islands, starts building as it pushes across the North Atlantic. Then typically somewhere in here, water temperatures get real warm, and you can see the thing just starts building Saturday into Sunday. And there we are, current time, seas 34 feet. According to that, and then some other, probably, I'll give it, let's go back here and just look at this. This is more like extra tropical. I said it was tropical earlier, but you can actually see a cold core low falling south and helping support this. So we'll keep our eye on that as well. To the South Atlantic, here we are, we're going again back a week, reviewing the past week. Sunday, August 10th. Little bit of a gale tried to develop here with, what was that, 24, 25-foot seas on Monday. Yeah, providing some limited swell for South Africa. Another low tried to build under the gap here, but really didn't do a whole lot. We're pushing out into Saturday, so just a day ago. Small little low, 31, 32-foot seas. That built just a little bit. We got 33-foot seas there. Later Saturday, and now here we are, Sunday, it's starting to fade. I mean, you just get the definite sense, at least what we've seen in the two southern hemisectors so far, that the southern hemi appears to be losing some energy. Let's go take a look over at the Indian Ocean. We'll see if the trend holds the same here. We're into Tuesday, Wednesday. A little bit, here's that gale that's pushed under Tasmania starting to build, but that really doesn't have any impact on the greater Indian Ocean. Here we go, little area, 32-foot seas, building to 34-foot or so. Where are we? On Friday, Saturday, taking a decidedly eastward track, but you get the sense there's some sort of a swell front trying to slowly push north here, mainly from an accumulation of a bunch of different weak low pressure systems. So some sort of energy pushing north, but not nearly as strong or as powerful or likely as long a period as earlier in the year. All right, so what is to come? We're going to focus now on the South Pacific. We are looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough, a push in the jet to the north. You kind of get the sense right here that there might be a trough. This is all zonal here, and then this is the opposite of a trough, a ridge pushing hard south into Antarctica. And you can't see it, but that's New Zealand, Australia here, South America over here. All right, so if you get a trough, a push into the jet to the north, that helps create a clockwise flow aloft. That also manifests itself down at the ocean surface. That is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean surface, impart energy to it, generating seas. As those seas eventually radiate away from the fetch area, the lesser period elements decay away, exposing the longer period swell elements, and that is what is known as ground swell. As that swell hits your beach, it turns into surf. All right, so maybe we have a little bit of a trough here under New Zealand, but otherwise nothing of any real interest. You can see it's not a great trough, but it's trying. Winds, 130 knots, that's enough for sure. Continue to put this into motion. There is a better trough 96 hours out on Thursday, the 21st of August, with winds to almost 160 knots. The stronger the winds, the better the odds of getting that circulation going. And that continues across the south central Pacific while slowly weakening into almost a week from now. And then we're out on Sunday. Another trough starts building with a decent flow. So there's some hope here. Nothing super obvious, but nothing, no big ridge pushing hard south, completely shutting us down. So there is hope. Looking down at the surface, we do see an area of 35 knot winds out of the east, but really that only gets you like a 13-second period swell, and the long 5,000 plus nautical mile journey up into the northern hemisphere, that probably isn't enough. Most of that 13-second energy would just decay away, and probably no rideable swell would result. You really want to see at least 40, preferably 45 knot winds or higher to produce meaningful swell with a long enough period. So we'll just keep rolling this out. Now here is a better looking gale. Let's go back a frame or two here. All right, on Monday, 18Z Monday, there's your 35 knot winds. The gale starts getting organized. Now San Diego's like at 118 west, so right along in there. 40 knot winds build, but almost as quick as it builds, this thing moves east of the Southern California swell window. As of this morning, all this was really going to be taking aim at Chile and Peru up in here. That still appears to be the case, but we'll confirm that when we get into the significant wave height models. Another low pressure system, all wind basically aiming south. Here's another little fetch on Wednesday evening, the 20th of August, with 45 knot winds pushing off to the east, still holding 40 to barely 45 knots. Continuing even into late Thursday and Friday, secondary fetch building behind that at 35 knots, and yet more on Saturday at 40 knots. So it looks like there is some potential in this area. We'll have to see. This actually looks better than what I saw on this morning's run of the model when I was updating the forecast. All right, so what are the effects of those winds on the ocean surface? We have 28-foot seas southeast of New Zealand. Another area of 28-foot seas, but they are east of the Southern California swell window and aimed south. So, and quickly all that just decays away as we get into later this evening. Again, you really want to see at least 28-foot seas. Here's the new low that starts building, 118 west, right on the hairy edge of the San Diego swell window, building to 32 feet, but all that east of the San Diego swell window. And you see it starting to fire up there with 33-foot seas, 34-foot seas, 35-foot seas. Another low starts building south of Tasmania about midweek. That'd be Wednesday the 20th. Sliding under there, 33-foot seas clearly in the California and Hawaii swell window, but as soon as it pushes into the West Pacific, starts decaying, hits the ice anomaly here, and a little bit of fetch though, continues to feed it 28, 29-foot seas, and there you go. It just continues in some fashion the whole way through till Sunday. So seems likely some surf should result from that. We'll go out 180 hours and it starts building again to 30 foot. So nothing huge, but certainly consistent background swell energy seems possible for anywhere from Hawaii into the U.S. West Coast, and certainly down into Mexico and Central America and Peru. And yeah, go south, it'll be bigger. The North Pacific. We'll check this out. I mean, officially August 15th is when I start looking, especially if you're in a strong El Nino year. You get tropical systems that form over here that can recurve. This year does not feel like one of those years at all. In fact, this year feels like one of those years that it's going to look like it's going to be a very late start to fall, because I'm not even, we're in summer, but in some ways it doesn't even hardly feel like summer. That said, there is another low pressure forecast for the Gulf, not producing meaningful seas, but just the fact that there's a circulation there suggests that there is some low pressure in the area. But again, my guess is it's going to be a slow start to the fall season. All right, so let's go to the North Atlantic. We're going to focus here and do a quick zoom in on Hurricane Erin, because that is the largest weather feature that is occurring pretty much anywhere on the planet right now. So here is satellite imagery, color enhanced tops. You can see a good solid, most of the energy right here on the east side of the eye, pushing up into the northeast quadrant. All that would be aimed northeast. This is Haiti down here, and the beginnings of the Bahamas off in this area. So relatively close to the U.S. East Coast, and certainly building. Winds are at 110 knots, and I think most of that fetch, the strongest winds would be right in here. High pressure off to the north, low pressure here, gradient between the two tightens up the isobars, creating the wind. That'd be 125 miles an hour, all aimed at the U.S. West Coast, anywhere from Florida on up to the northeast coast. Here's the GFS model. We'll just run through. Here's the position, Haiti, Puerto Rico right there. So here is a variety of tracks from a whole bunch of different models for Erin, but you see all of them tightly pretty well clustered, none bringing the eye anywhere meaningfully near land. This looks more like a fish storm, which is a good thing, but a great potential for producing swell, especially in the next 72 to, let's say, maybe 78 hours when it's making this curve. Once it starts pushing away from land, the fetch running counterclockwise, but if the storm itself is racing off this way, even if you have east fetch, it's going to have a really hard time getting traction. Whereas down here, all the fetch is in the east to northeast quadrant of the storm, and all this pretty much just aiming anywhere from central Florida the whole way up into Nova Scotia. Tropical storm force wind speed probabilities were down at 10%, 15% of probability of tropical storm force winds over the Outer Banks. Now again, this is not a guarantee. You've got to keep your eyes on this. Do not take it for granted if you live anywhere in this region. But at least at this moment, it appears that the odds are not in favor of a landfalling hurricane. Track positions, max winds. Okay, we're at 110 knots, 125 mile an hour. We go out 24 hours or so. Erin supposed to rebuild with winds up to 125 knots. That's 145 miles an hour. That gets you into Cat 4 category storm. And then as it starts accelerating off to the northeast, you see the wind speed steadily dropping, going out 4 days and 5 days. We're down to minimal hurricane force winds. Here are the Great Circle Paths. This goes into Cocoa Beach, Florida. This is Erin back on Tuesday night, the 12th of August. We'll put this into motion, then we'll run through a couple of other locations. You see there's the 105-degree Great Circle Path into Cocoa Beach. Continuing east, but notice it's starting to lift northeast. This was on Friday, and here we are on Saturday, pretty much coming up somewhere around I'd say about the 110-degree track. Let's see where we go. The cutoff here, with the Bahamas, is at 115 degrees, and we're just barely in it. And then you see the core of it as of Sunday 12Z, right on the hairy edge of that cutoff, but not getting cut off. Continuing into Sunday, right there, and then lifting north as it moves off the coast. You're just straight off of Cocoa Beach on, this would be Tuesday night, and then I'll run it through here. All right, and you get the general idea. So let's go back, and we'll play the same game, but we're going to do this relative to, let's say, Jacksonville. Okay, Now let's do Cape Hatteras. I don't want to bore you with doing too much here. Okay. Now relative to Cape Hatteras, you see you have a lot more exposure to the south here. This system, as it starts lifting north, right up the Great Circle path, that looks like the 162-degree path into Cape Hatteras, right there, and then turning off at the last minute. You see it starting to head northeast. Here's the Great Circle path in. Fetch. Still around the north side of the storm, pushing into the Outer Banks, or pushing swell towards the Outer Banks before racing off to the northeast. And then we'll do one more of these for New Jersey. We'll get it re-queued back here a little bit. You can see, we'll just take it back to about there. Okay, here's the 150-degree path. Here's the 171-degree path. This is just like into just regular old mainland New Jersey. Coming right up the 171-degree path, almost 170 degrees there for, 170 degrees for a while, and then pushing off. Sort of seems like somewhere right in here is where the largest amount of energy is going to hit, just eyeballing this thing. We'll just run this thing out the whole way so you can see where it goes. We're out 140 hours, 174 hours, targeting Europe beyond that with solid swell energy. And then here we go. We're just looking at the general North Pacific now, North Atlantic now. Erin, of course, the other tropical or extratropical system, 18-foot seas, something like that. Oh, let's see if we can pick up what the highest seas supposedly per the wave model are. 57.4-foot seas at 18Z. That's about, I'm just doing this off the top of my head, maybe about 2 o'clock on Wednesday afternoon in the Cape Hatteras area. 54 feet right, then starts losing sea heights. Oh, but then, I see what's going on here. Okay, so the fetch actually going this way. As the storm starts pushing this way, and the fetch on the, let's see, it's counterclockwise, right? Fetch on the north side of the storm lines up with the direction of travel, and then you get explosive sea growth according to the models from 59.9 feet to 65 feet, and then down to 59 feet. It's probably losing wind energy by that point in time, and then down into the 50-foot range. And let's just push this on out. And then here we are a week from now with 37-foot seas targeting Europe. I mean, this is a good setup for potential real swell for all these locations in here, if it does what it says it's going to do. To the South Atlantic, we're just looking for what the significant sea height forecast is supposed to be. I'm looking for anything really 25 feet or better. We got some 20-foot seas targeting South Africa on late Thursday, the 21st, but nothing super obvious. Then we get an area of 26, almost 27-foot seas targeting South Africa well on Saturday, lifting off to the northeast. That definitely would be a swell producer, but again, notice the fetch right up along the coast, generating 22, 23-foot seas. Another system developing a week out. We'll see what happens. Not sure whether that's believable or not, but something to keep your eyes on. And then finally, to the Indian Ocean. We're just seeing how this does. 26-foot seas here, building to briefly 30 feet. That could produce surf for the Mentawai Islands, Western Australia, parts of southwestern Australia. That fades out as we get into Wednesday. Another system develops with 36-foot seas, maybe 36 feet. Tracking off to the east, again, you see a swell front emanating off to the northeast from that. We're into Saturday, pushing into southwestern Australia, bound for the Mentawai Islands and Indonesia. So swell for sure. And then there we are, 180 hours out, some sort of more activity southeast of Africa. So the summertime or wintertime in the southern hemi pattern is not over yet, at least not for the Indian Ocean. Local wind forecast. We've been bouncing all around the planet, but zooming back into California and the Hawaiian Islands. California here, Hawaii here. This would be Southern California right here. There's Point Conception, Monterey Bay, San Francisco Bay, Northern California, and the California-Oregon border there. A high-pressure system, not particularly strong, 128 millibars, trying to sort of ridge into the coast, but a light wind regime, and this has been pretty much the case for a while now, allowing water temperatures to warm up pretty nice. Trades 15 knots for the Hawaiian Islands. Let's get into Monday, see what's happening. Same sort of deal, light pressure pattern. Trades just kind of standard thing for the Hawaiian Islands. Even into Tuesday, no real change. Here's weak low pressure in the Gulf of Alaska. So we get into Wednesday, but notice high pressure builds, low pressure inland, heat low, tightening up the isobars, creating wind, and now we're back to the 20-knot northwest wind raking down the north and central California coast. Trades looking like 10 to maybe 15 knots for the Hawaiian Islands. Same deal on Thursday. This would be generating wind swell mixing in with whatever southern hemi swell, background southern hemi swell is hitting. Trades 15 knots for the Hawaiian Islands. Friday, same sort of deal, but the gradient lifts to the north, a lighter wind regime for central California. Trades 15 knots for the Hawaiian Islands. Same deal on Saturday. The winds not as strong. Yes, there'd be wind swell, but this is all basically 15 knots, so that we're talking, 7 seconds, 6 second period wind swell sort of thing. 15-knot trades for the Hawaiian Islands, and we'll just get into Sunday here. Same sort of deal. Sunday, high pressure looks to be setting up, making a bigger footprint over the Gulf of Alaska. If you're on the Pacific Crest Trail and you are at the intersection of in Yosemite of that and Tioga Pass Road at 8,700 feet, here's what the temperatures will be. This was last run on Saturday, so a day ago, but it's pretty close. Temperatures 50 to 55 degrees. Then as we get into, it looks like about Wednesday, a little bit of a warm-up, 55 to 60 degrees and 65 degrees. Almost pushing 70 Thursday, Friday, Saturday, Sunday. Then you get the sense maybe a bit of a drop off, but almost at the end of the image you can see maybe something building. So generally in the Sierra, I'll call it seasonal temperatures, maybe even a little bit cooler than normal. So if you're backpacking, not actually a bad deal. Surf forecast for a couple of select locations, starting up North Columbia River there, again, the Oregon-Washington border. Surf heights, 4 feet today, fading out as you get into Monday in the 2.5 foot range and slowly trickling down into Thursday. Then coming up again, but still only in the 2 to 2.5 foot range. Winds not bad. Swell, Monday, 3 feet at 9 seconds, we'll call it, and trickling down from there. A little bit of southern hemiswell trying to show in at 1 foot at 14 seconds or so. And then more wind swell as we get into next week and in the 3 foot at 7 second range. So that's like 2 foot surf. Down to Santa Cruz, surf heights, we'll call it 2 foot, something like that. And as you get even later into Monday, even smaller. Then rising some as we get into Wednesday and Thursday. My guess is most of that is wind swell with some background southern hemiswell intermixed. And then holding in about the 2 foot range on through into next weekend. Swell heights, let's see. Here we go. 1.2 feet at 15 to 16 seconds on Tuesday. That's and you see 1 foot at 16 seconds. So background southern hemiswell moving on Monday, building a little on Tuesday. 1.5 feet at 14 to 15 seconds on Wednesday, and still holding into Thursday with wind swell building intermixed. And that same sort of pattern just continuing the whole way through the work week and next weekend. San Diego here, surf heights, 2 feet, it says 1.5 feet, but I'd say 2 feet, 2.5 feet, and continuing the whole way through light winds. Where is our southern hemiswell? 1.4 feet at 16 seconds, and then the wind swell, 2 feet at 6 seconds, beats it out. And then, okay, here we go, 1.7 at 14 seconds, 13 seconds. This is on Thursday. But there's some southern hemiswell the whole way through here. Then as the wind swell dies out, you're into Saturday and Sunday, 1.7, maybe 1.8 feet at 14 seconds all the way through. So rideable surf, nothing huge, but something to ride for the foreseeable future. Oahu also expected to get some of the action. South Shore here, surf heights in the 2-foot building to about 2.5 feet as we get into Thursday, Friday, and even into next week. Trades, you see them here, 15, 20 knots, pretty much the standard drill here. Surf heights, all right, 1.5 feet at 12 seconds, 1.4 feet at 12 seconds, a little more southern hemiswell, almost 2 feet at 14 seconds into, it's actually Wednesday night when that's the really first nice pulse of southern hemiswell hits. Then it continues hanging in like the 2 foot at 13 second period range, fading out as we get into the weekend. All right, the effects of Hurricane Erin on the U.S. East Coast as it relates to surf. Surf heights, you can see it plain as day here. The swell coming in about midday Wednesday, peaking in the 10-foot range. Winds, some version of north at 15 knots, and then slowly trickling down, but still not out as we get into even next weekend. Let's see what we can get for swell heights out of this. Peak height, 7.4 feet at 14 seconds. That is definitely solid and pretty much out of the east, almost northeast, 80 degrees. And then slowly trickling down 4 feet at 13 seconds, even on Friday morning. Saturday, 3 feet at 12 seconds. So it just continues. It's really going to agitate the ocean there a bit, and it's going to take a while for that swashing around to finally filter out. So a good run of surf for the Florida area. Local winds, a little bit of an issue. Do the best you can. Cape Hatteras Lighthouse, this is to get the brunt of the swell. Is it really going to be 25 feet? No, it's not, but 15, 18 feet for sure. I saw that. I did some manual calculations. You see your winds here out of the north at 30 knots. You know where to go to try to get some of that swell because it'll be coming from the south. Swell heights, 15 feet at 16 seconds. That'll probably be swamping most locations. That's a lot of swell energy, even if this is overstated, which I'm not sure it really is. But you see, as you get later into the period here, swell heights moderating into the 8 at 12 seconds, 6.5 feet at 12, 13 second period. So plenty of swell. And then finally up to New Jersey, surf heights peaking about 12.5 feet sometime early on Thursday. Winds out of the east at 15 knots sort of thing. Let's go look at swell heights. 7.3 at 17 seconds. That is a long period swell. It's a lot of energy for most sandbar breaks. Probably a more protected break would be a better call. Anyway, you see it here. Swell heights slowly fading down 4 feet at 12 seconds as we get late Friday into early Saturday. And something probably rideable even out into later Saturday or early Sunday. All right, let's go take a look long-term, the long-term outlook. What are the two major weather oscillations that affect our potential for surf long-term? They are, of course, the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start with the MJO. There are two phases to it, the active phase and the inactive phase. They rotate around the planet west to east on the equator. One phase on one side of the planet, the other on the other side, rotating around like that. The active phase is our friend. It's a low-pressure system. It takes warm, moist air at the ocean surface, lifts it aloft. That warm, moist air eventually gets caught by the jet stream, feeding energy into the jet stream, making it stronger, helping dig out troughs and support storm development and therefore surf production. The inactive phase does basically the opposite. It is a high-pressure system. It has falling dry air that cuts off the energy supply to the jet stream. The jet stream gets weaker and splits. Just seeing how there is a lack of tropical activity in the Pacific and there is a lot of tropical activity in the Atlantic, one would probably surmise the active phase is somewhere over the Atlantic. We're going to look, though, at data from the TAA buoy array. This is a series of buoys strung across the equator in the Pacific. East Pacific here, West Pacific here. This is the equator there. International dateline 180 west. We're just looking at the arrows. These are wind directions and speed. The longer the arrow, the stronger the wind. So strong trades from the east and the East Pacific, strong trades over the Central Pacific, moderate trades over the West Pacific. The active phase of the MJO moderates or dampens trade winds. The inactive phase, because it's a high pressure system, feeds up with what generates trades, which is high pressure, and amplifies the trade. So in the Pacific, we see, at least in the East Pacific, the little arrows here, they're not particularly strong, not really going anywhere, so kind of a neutral, normal weather pattern. Kind of the same, maybe a little bit stronger here over the Central Pacific, and just barely a little bit stronger in the West Pacific. So no clear signs of an active or an inactive pattern over the Pacific. Let's go look at the forecast. All right, so here we go. 850 millibar zonal wind anomalies. The east-west component of the wind, but not isolated to the Pacific. Now this is for the whole planet right here. We go look at this 180, that's the date line. Okay, so that's in the Pacific. The far west Pacific starts at 125 east, so roughly right there. Okay, the Atlantic, let's see, Florida is at about 80 west, so somewhere right there. The oranges and yellows are westerly anomalies, indicative of the active phase of the MJO. The blues, purples are easterly anomalies, the inactive phase of the MJO. So just as we kind of surmised, inactive phase over the, and let's see, Ecuador, that's on the far east Pacific, that's about 80 west, so somewhere right around here. And you see easterly anomalies over the Pacific, westerly anomalies over the Atlantic. No wonder Erin was as strong as it was and where it was, the active phase likely feeding it. Now, the interesting thing here is going out, this goes out 2 weeks. You see westerly anomalies. Right now, they're weak. No wonder there is not a lot of storm development in the Pacific, but as you go out 5 days, you see westerly anomalies starting to build into the West Pacific, making it about halfway across what I call the Kelvin wave generation area. It's the West Pacific where when the jet stream is coming off the maritime continent or off that area, this is where you feed energy into the jet stream, and then the jet stream gets its momentum to make it the rest of the way across the Pacific. Okay, but the West Pacific is key for having westerly anomalies there in the active phase, perhaps building into it. So this looks like, yeah, we'll be down for about a week, but after that, things might start looking up. Let's go look at some models going out a little further. Outgoing long wave radiation forecast going out 2 weeks. What's that mean? It's just cloud cover. If you have the active phase of the MJO and it is a low pressure system and it is taking warm moist air and sucking it up, that warm moist air eventually is going to condense as it hits cooler air aloft, creating more clouds. Okay, so that's what this chart is. Outgoing long wave radiation. More clouds, you get less sun reflection off the ocean surface. The blue, negative anomalies. That would be the active phase of the MJO. Oranges and reds, inactive phase. So South America, Central America, Maritime Continent, Australia, Africa there. And you see little bits. So the active phase, at least according to this, maybe more in the Indian Ocean, the Atlantic. But if it's anywhere over here and it's not here, it affects the Atlantic just the same. And this is suggesting inactive phase over the Pacific. 5 days from now, inactive phase starts fading, active phase starts moving more over the maritime continent, dead neutral 10 days out, but 15 days out, active phase back to the Pacific, inactive phase moving toward the Atlantic. Now that's the statistic model. The dynamic model, pretty much showing the exact same thing. Inactive phase holding a little bit longer, active phase maybe a little stronger. Let's go look. There's the last frame from the statistic model. Last frame for the dynamic model. They're pretty much in sync. Phase diagrams for the same two models. How do you read this? Well, the active phase. This is mapping where the active phase is and how strong it is. And since the active phase is our friend, I'm very interested in that. Active phase moves from west to east, from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States. Remember, this is on the equator. Over Africa, back to the Indian Ocean. The heavy dot right there is where the active phase is, and the further the dot is away from this circle, the stronger it is. If it's way out here, that's considered strong here. Modest at best. So a modest active phase over the next 2 week forecast making it to the maritime continent. One member has it almost making it to the West Pacific, but in either case, very weak. The dynamic model, the GFS model, basically painting the same picture, it moving to the maritime continent and being weak. The CFS model, this goes out a month now, 850 millibar zonal wind anomalies. Again, the reds, are west anomalies, the blues, easterly anomalies. This chart actually has the MJO highlighted on it, the black contour. You see active phase, this was, a week ago. Over the far east Pacific, my guess is it's moving into the over the western Atlantic right now. You see the westerly anomalies right there. Here's a little hint of an inactive phase, but they're showing hints of stuff, but this really suggesting no clear, coherent MJO pattern indicated. That's pretty typical for this time of year. Anyway, easterly anomalies in control for the next 3 or 4 days, but then this shows westerly anomalies starting to build in the West Pacific even 3 days from now, holding for pretty much the next 2.5 to almost 3 weeks. So maybe another shot right here, little hint of an active phase, maybe giving us one last push from the southern hemi as we get into the latter part of August. Then finally, the CFS model going out 3 months. Past performance is down here. The forecast is up here. This you can see, date line running right up the middle. West Pacific, far West Pacific, let's say 130 east, so somewhere right around here. This model's saying the same thing. Within the next 3 days, western anomalies start building over the West Pacific. And then this is the pattern. Actually, this is an improvement from last week. Westerly anomalies making it to, probably, let's say 165, maybe even 170 west, and holding, and then actually building as we get into October, November. I don't know if I believe that. Let's overlay the MJO, just see what's going on here. All right, so we're in the inactive phase of the MJO over the over the Pacific right now. The Atlantic somewhere off here. See the westerly anomalies, that probably suggests favorable tropical development. But here comes the active phase into the Pacific. Yep, about a week out. Westerly anomalies building ahead of the active phase and then pretty much continuing unchanged. Now remember, there was a massive active phase of the MJO that this model was just hyping to death for months. That's all gone now. This suggesting a much more modest active-inactive pattern. But still, these westerly anomalies, I think that is really key to the future for our winter in the Pacific in terms of storm development. The more westerly anomalies, the better your odds are for storms development because that just feeds the jet stream. Let's overlay the low-pass filter. This is the high-pressure, low-pressure bias. Solid contour, the low-pressure bias. We want as much of that in the Pacific as possible. You can see it made a major nudge off to the east here and is currently at, let's see if I can even do this. I got to do it manually. It's at like 160 east, and his forecast holding, if not nudging even a little bit further to the east, and with a second contour building right at the hairy edge to the West Pacific as we get into the latter part of September. So this is all pretty much what the model has been saying all along. Here is your high pressure bias. This is your La Nina indicator, and it's setting up over, just off of the California coast. This is on the equator, but the equivalent if you go south from California to the equator. Weak high-pressure bias with a second contour also building. So this dividing line right here is key, somewhere around, I'll call it 160 to 165 east. So half the West Pacific with westerly anomalies, the other half with easterly anomalies. Where they converge, there's going to be an updraft area. Westerly anomalies, easterly anomalies, they collide and then head up. And that's the dividing line. And I think that's what's going to be the setup or the characteristic for our coming winter. So, not too bad of a setup. Probably offshore winds for California. Rain might be a definite issue. The jet stream, some sort of a weak La Nina, but a weak La Nina with weak El Nino characteristics in the far west Pacific. And we've been kind of saying that for a couple of weeks now, and there's nothing in this model that suggests that that still is not going to be the case. All right, let's go see what's going on subsurface. This gives us yet more clues, and we're moving into the El Nino, La Nina portion of the discussion. Clearly La Nina influenced. Data again from the TAO buoy arrays, a series of buoys strung across the equator. These are the anchor lines on the buoys. The X's are sensors. They give you subsurface water temperature. When you're in La Nina, trades are stronger than normal. They take all the warm water in the Pacific and push it into the West Pacific. That's clearly the profile we see here. 29-degree isotherm. I think it's backtracked maybe 1 degree from what it was last week, from like 178 to 177, which is no big deal. 28-degree isotherm hovering right around 165. I'll give it 164 west today, so no real change there. 24-degree isotherm, it might have been at 117 last week, so it's backtracking a little, suggesting trades blowing pretty good over in this area. But again, it is not the actual water temperatures, it is the anomaly, the difference from normal for this time of year. You see we have warmer than normal temperatures in the west and a little ball of it here off the east, but in between, upwelling. So what's that really mean? If you have easterly anomalies blowing, they're going to take the warm water that is in this area, start pushing it west, and what happens is normal water temperatures down here, colder temperatures, and you can see it plain as day, like 13, 14 degrees centigrade, start upwelling, and the depth of these isotherms get comparatively shallower in the east, and that's what's happening here. It looks like a ball of cold water, but what it really is, it's just like, in California, when you get the northwest winds blowing, they create upwelling and the water temperatures drop. That's exactly what's happening here. It's just an upwelling pattern. Cooler waters making it to the surface. The deal is, though, cooler waters don't prevent, they actually prevent evaporation. That supports high pressure building on top of that. And that's sort of how La Nina gets its roots into the Pacific. Let's go look at some other data. Same sensor data enhanced by satellite images. It's basically painting the same picture, though last week cooler waters were up here. Now it seems to be warming a little bit. This dividing line is right at about 145, 150 west, meaning that the cool upwelling is limited to, I won't even call it the East Pacific. It's like the Central Pacific, but not even that far deep into the Central Pacific, with a pretty good wall of warm water here. Let's keep going. Here's the satellite data. This is showing you the height of the ocean surface. Strip away the waves, the winds, the tides, and is the height higher, the sphere of the ocean, is it higher or lower than normal? Why does that matter? Cold water at depth contracts, you'll end up with a divot on the ocean surface. And if you have east winds blowing over top of that, and it's scraping out surface water, pushing off to the west, you'll get a divot. Likewise, warm water at depth expands, create a bump on the ocean surface. So, here's the equator right here. Ecuador is right there. Galapagos there. There's the international date line. There's New Guinea there. Just 5 degrees north and south of the equator is all that matters. We see negative anomalies here off of Ecuador and the whole way to right about there. So what is that? Yeah, 150 west. No big surprise. The difference this week is warmer than normal temperatures, or at least semi-positive anomalies, have made a little bit of an incursion to the east, suggesting maybe trades are weaker than normal in this area. Hopefully it holds, but again, this updates every 5 days. I wouldn't be surprised to see this gone another 5 days from now. Upper ocean heat anomalies. All right, so this is the West Pacific here, East Pacific here, upper 300 meters of the ocean. Here was our La Nina from last winter. Colder than normal temperatures in the east. Somewhere in March, that all shut down. We got a push of westerly anomalies and warm water making its way across the equator. We almost got excited and go, hey, we're going to be pure ENSO neutral. And then just like that, in a period of about a week and a half, we went from neutral to here comes this upwelling pattern. And the assumption was there were easterly anomalies here, but I really couldn't find it on any of the charts but it happened nonetheless. There's no way you're going to get upwelling if you don't have easterly anomalies. Anyway, it happened. You see it built. Now it's sort of retrograding off to the east from 140 out to about 110, something like that. I sort of monitor where this is going all the time. So this is nowhere near as bad as any of this last year. We'll see if this grows and takes over a larger area. Really, the El Nino, La Nina, MJO cycle starting to become pronounced somewhere around mid-August into September, and runs the whole way through fall and the early part of winter. See surface temperature anomalies using the traditional method. No doubt everything is much warmer than normal, but here on the equator, and that's all that matters, 5 degrees north and south of the equator, here's that upwelling cool pool, presumably where easterly anomalies are stronger than normal. Again, we've been talking about this, the westerly anomalies and the dividing line between the westerly and the easterly anomalies being somewhere right around here. At least that's what the projections show. This kind of suggests that too. Easterly anomalies upwelling here, westerly anomalies, and I guess you'd call it downwelling to about here. The dividing line right there. Again, the jet stream would be coming right over this, picking up lots of energy. Even if there's easterly anomalies, it's going to have momentum to help push it at least towards the Gulf of Alaska as we get into the winter months. But right now, this is pretty much unchanged from last week. Sea surface temperature trend over the past 7 days. You clearly see cooling the whole way from the Galapagos out to about 140. Warming over here in the far west Pacific. Again, the dividing line, who knows where it is, somewhere around in here. But the cooling trend, a little more pronounced than that last week, but not horrendously so. I mean, it's a balance of warming and cooling almost. The alternate sea surface temperature anomaly chart, pretty much the same as last week. Again, you know, running the cool anomalies running from just a little bit west of the date line to about the Galapagos Island. I think this overstates the cooling. The other chart probably understates the cooling. And the 15-day trend, the equator right here, Ecuador right there, Galapagos there. Again, this mixed pattern of warm, cool. I don't know, do they balance out each other out? Hard to tell. Sea surface temperature anomaly trend. This is just raw data. It's not corrected or not much corrected. Probably a pretty good indicator of what's going on. This is in the Nino 1.2 region, the region right there by the Galapagos. And Ecuador, today, temperatures 183 thousandths of a degree above normal. We were up to almost 4/10 of a degree, a little bit over 4/10 a degree there for a minute or two. But in general, the trend on the high side of normal, which is kind of what the official charts look like. The Nino 3.4 index suggests, here we are, temperatures 680 thousandths of a degree below normal. So that would be, the cutoff for neutral is half a degree below normal to half a degree above. Anywhere if you're in between, that's just considered, normal variation. But now we're kind of, just for like 4 days now. Well, actually, half a degree started July 20th, and we've been toying at times with being below that. I mean, we're right on the hairy edge of some sort of a weak La Nina, and we'll see whether this holds or not. Right here is the Nino 3.4 sea surface temperature anomalies. The official value, these are updated weekly, but it is corrected, and I think it's corrected just a little bit, making it warmer than it is. This says minus 0.3 degrees, and we've been there for now the past 2 weeks. So you can see the trend definitely getting cooler, but according to this, not La Nina, it's just still ENSO neutral. What does the atmosphere think is going on? Well, we look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. And this is probably as good as any sort of a measure, I think. If pressure is lower in Tahiti, which is in the Pacific, the index goes negative. If it's higher in Tahiti relative to Darwin, the index goes positive. Today, plus 4.49, which is like just weekly positive. And let's go back the past month. we see, yeah, we're up at 14. This is super sensitive to even like local thunderstorms. I mean, I'm exaggerating a little bit, but local thunderstorms, certainly the MJO. The trend looking at this has been on the weak side of positive. 30-day average takes some of the guess out. The value 2.87. If you're in La Nina, I'd say you're up at like plus 12 or 15, something like that. So again, and what's the trend been in the past month, if anything? Heading down. So that's actually good. That suggests ENSO neutral. The 90-day averages is your El Nino La Nina indicator. Again, just barely positive, 3.35, where were we a month ago? 1.79. Okay, so let's go look at a graph, see if that will help give us a little more perspective. Here's the 30-day running average value right there. Neutral, the high side of neutral here at +7, low side -7. About as neutral as you can get, and we've been hanging there since June. So that makes me feel a little bit better. But again, the MJO and ENSO really come into their prime more in the fall. So we're still kind of waiting to see how this goes. And I think, you know, we're not. We're thinking we're in late summer, but I think in the reality we're like in midsummer. Think of today really like beginning of July, mid-July from a atmospheric perspective. The sea surface temperature anomaly forecast for the Nino 3.4 region from the CFS version 2 model. Raw data. All right, so we saw that temperatures were, let's see, we'll call it mid-August, so that'd be right about there. Officially, they were at 0.3 degrees below normal. That's pretty much what this is confirming. And it shows temperatures going down to 1 degree below neutral. But again, the half degree, minus to plus. So you really don't start dipping into La Nina territory until you get into September, October, November, December. Yeah, I mean, this is kind of looking like what you'd call minimum La Nina territory. It is not the max that the temperatures are. It's sort of a running average over a 3-month period, over 5 consecutive overlapping 3-month periods. Then the PDF corrected, which is, I think, where NOAA really goes for their official forecast. We'll call this 0.85 of a degree, and again, you're only for like 1, 2, maybe 3 months, something like that. So I don't know, maybe another Modoki La Nina. All right, well, the swell pattern has settled down a bit in the Pacific. There is a series of, I'll call it background southern hemi energy, you know, waist high kind of thing for California and Hawaii for the bulk of the work week and even into maybe next weekend. So rideable surf, another little gale forecast down south that should provide yet more activity working its way north eventually. No sign of the North Pacific doing anything yet, and not even any hurricane activity. The main focus of activity, at least for this week, just like the title says, is Hurricane Erin. And for the east coast of the United States, the folks that surf over there, they've been dying for waves. It's not been a great summer. So finally, some much needed relief and potentially another system behind that. We'll see how that all plays out. Looking long term, looks like some flavor of, I don't even want to call it La Nina. I'll call it a Modoki La Nina as we get into the fall and winter months. But with west anomalies over the far west Pacific, that should do well for the Jetstream. And maybe I'm just being optimistic, but I'm hoping that we will have a reasonably decent swell pattern for Hawaii and California, with the potential for trades or offshore winds in California. Maybe a dry year again, a dry winter for California. We've had 3 years in a row of normal precip and snow, so that's kind of the price you pay for living in California. It gets dry sometimes, and sometimes for very long stretches of time. We'll see. The consensus model for the La Nina El Nino forecast comes out probably tomorrow on Monday, so go take a look at that and see what all the other models say. We've been focusing a lot on the CFS model. We'll see if it's as cool as what the CFS model says. My guess is probably not. Anyway, that is it for this week. If you enjoyed the video, give us a There we go. Thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. Comments, questions, always welcome. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We'll do it again next week. Same time, same channel. Go surfing, get some waves, stay safe, and we'll see you in a week.